Okay, so I think we'll make a start. The first part of the material, we've got a little bit of time just to check that everybody's set up and ready to go. So we will be able to address any problems as we go forward. So welcome everybody to the second day of our containers course, Reproducible Computational Environments Using Containers. And this section today is going to be looking at Singularity. So yesterday we looked at Docker, and hopefully you all found that a very useful introduction to the Docker container system, and you learned how to work with Docker, how to run containers, how to build your own containers. And we're going to actually leverage some of the skills from yesterday in today's material. We're going to be using Docker a little bit later as a way to run Singularity. So that will be an interesting example of one of the benefits of Docker. But the core topic for today is looking at the Singularity container system. So hopefully you have, as I mentioned before, but anybody who's just joined in the last couple of minutes will not have heard. Hopefully you've seen the setup instructions. There was one set of setup instructions for yesterday, which covered everything for both Docker and Singularity lessons. And hopefully you've been able to create an ARCHER2 account and be able to sign in. If you haven't, do let us know in the chat, and one of the helpers will assist you. I'm going to put up a little poll just to check that to check how many people are able to sign in successfully. So let me just do that now, and I'll leave that on the screen, and I'll then continue with the material. Okay, so let's that up. So hopefully you can see that poll, and hopefully most of you will be okay. But if there are any problems, the helpers will assist. So just to go over a couple of points from yesterday. So just a reminder that this course is being run under the ARCHER2 code of conduct, and so everybody involved in the course, both the attendees and the instructors and helpers, are expected to adhere to that code of conduct. I'm putting the link to it in the chat there for you. I'm also putting the link to today's Singularity material, which hopefully you can access. And we're going to get started with episode 1, with the Singularity Getting Started episode. Just to say that this material is fairly new material. It's under a process of constant evolution at the moment. We're updating it and improving it over time. It's been taught a few times, so we know that the general structure works, and all of the material that's in here is being updated to take into account the fact that the underlying tools are changing very frequently. So this is material that is up to date. It's been updated with the latest versions of the software that's on ARCHER2, and hopefully everything will fit in with the current state. But of course, these things are changing a lot all the time. So we are kind of evolving the material as time goes on. So as I have highlighted at the end of the material, we are always very happy to receive any comments or suggestions on how the material can be improved. So anything that you see as we go along, do feel free to make comments or make a note and let us know at the end in your feedback. The other thing to just note is that the timing of this, again, because things are changing all the time, the timing is a rough guide. We'll aim to keep to it, and we'll certainly keep to having a break in the middle and keep to the lunch times and the restart time after lunch. But the break may move around inside this section, so I have a feeling we'll probably get to the end of section 5 before we have a break, rather than the one before that, using Singularity containers to run commands. But we'll see how things go, and so there is time built in for us to be able to pause if there's any issues or questions as we go along, and likewise do feel free to put questions in the chat as we go along, as you were all doing yesterday. It was great to see so many questions yesterday, and either myself or the helpers will be able to assist and answer questions as we go along. Likewise, if you want to ask a question, feel free to put up your hand and then unmute and ask a question. Either option is absolutely fine. So getting started with Singularity, the work that we're doing today is going to be in 2 general sections. So part 1 we're going to go through this morning, which is this kind of basic usage, working with images, and we'll see kind of a parallel to what we saw yesterday, how to get hold of images, how to run containers from them, and we'll look at some of the kind of specifics of how Singularity works and how it differs from Docker. And then when we come on to the more advanced material, we'll look into actually how to create Singularity images, and in particular running parallel codes, and we'll be able to see, hopefully we'll get to the point where we can show an example on ARCHER2 of running a parallel job from a Singularity container. Okay, so what we're going to do for the first bit here is just run through some general background, a bit like we did yesterday, and hopefully that will give a bit of time for anybody who is having problems with signing in for the helpers to investigate that. But I will pause when we get to the end of this general introductory material just to make sure that everybody is okay with that. So what is Singularity? Singularity is another container platform, and as you'll see, it is in some ways very similar to Docker, certainly from a user perspective. So when you use it, it looks like it's very similar. Some of the commands will appear very similar to the commands that we used with Docker. But in other ways, particularly in the way that it's designed, so in the architecture of the Singularity system, it's quite different. And these differences are such that it helps for running on shared platforms, and particularly on distributed HPC infrastructure. As we heard yesterday, Docker is not ideal for running on these platforms. And as is highlighted here, system administrators will not generally want to install Docker. In fact, I think it's probably very unlikely to see Docker on large shared computing platforms because of the way that Docker is designed. And this is not a criticism of Docker in any way at all. It's just a design decision in the way that the system has been built, and it provides Docker with a huge amount of power and flexibility. But it does mean that there are security issues if Docker is run on a shared platform. And the issues with that are that, as we noticed yesterday, when you run a Docker container, you end up in the container as root. And if you're on a shared platform and you can, for example, bind directories from that platform into your Docker container, it provides people with the potential to have effectively root access to files, but also more fundamental issue is that the design of Docker has a Docker daemon that runs on the system as a process, as a master process that runs in the system that orchestrates all of the Docker system. And that daemon runs as a kind of privileged root process. And so to be able to interact with that, you also need these kind of privileges. And there is work that's being done to try and provide options for using Docker in a sort of less privileged, in a standard user account environment. But at the moment, the design of the system is such that it presents a number of security issues on shared infrastructure. And that is why Docker is generally not, or is not provided on those systems. So Singularity, on the other hand, is different because it runs entirely within what we call user space. So as an end user, you can run the Singularity executable and you don't need any special administrative privileges yourself. So your user account does not need any special administrative privileges to be able to successfully interact with Singularity and to be able to run containers. As we'll see, when we come to building containers, you do generally need to have some sort of root or high-level privileges within the system that you're building containers on. But we'll look at how we tackle that and how we work around it as we go forward. So this is another container platform and is effectively it's a parallel in terms of its capabilities in many ways to Docker, to the things that we saw yesterday with Docker, but it is different in the way it's designed. And I guess that's the main kind of takeaway from this introduction, and that's why you tend to see it on large-scale infrastructure and platforms like ARCHER2, as we'll be using today. So I thought it'd be useful to give you a little bit of background because, as I mentioned at the start, things are changing very frequently. This is an area where there's a lot of development. These tools are under constant development, and the functionality and the features of these tools are changing over time. So I wanted to give you just a little bit of background, also because there are some changes going on at the moment with Singularity, and you may see different names, and some of these things may become clearer over time. But it will hopefully make things easier for you to understand if you start working with these tools more significantly in the future. So Singularity is an open source application. It was initially developed within the research community and was made available as a kind of free open source project. What happened in the sort of fairly recent past is that the project was what's called forked. So any of you who work with open source software, if you write open source code, you'll know that there is the option to fork in GitHub projects. This is a kind of similar thing that's happened. Basically, another group has kind of taken the open source code on and has started developing it in a different direction. And what's effectively happened is that the project has split into two separate projects. So a fork was taken by a commercial entity, Scilabs.io, and they are continuing to provide a free open source version of Singularity, which they call Singularity Community Edition. But they're also providing pro and enterprise editions on a kind of commercial basis. You can look at the Scilabs.io site and you'll see all the details of the different versions that they offer. What slightly complicated this was the fact that there were then effectively two different things called Singularity. One was the fork that had been taken by Scilabs.io, and then there was the kind of original Singularity team who were continuing to develop their own Singularity. And obviously that was not something that's sustainable because it gets very complicated. So what's happened quite recently is that the original open source project has been renamed to Aptainer, and it's been kind of moved into the Linux Foundation. So at the time of writing, Aptainer is still working towards initial release, and that's actually the case now. So it's not yet reached initial release. And so for now, there are Singularity is available both through Scilabs.io and also through the original Singularity project. And it's a little confusing because the version numbers, they're both at sort of different versions. We will be working with versions of Singularity that were released prior to things kind of diverging on these two different routes. So for the versions that we're using in this particular course, it doesn't really matter where you actually get the code from, whether you get it from the Scilabs.io project or from the original Singularity project, the versions are effectively the same. But this is really just to highlight to you that things are kind of changing and that they have diverged. And of course, when Aptainer starts releasing new versions under their own name, I guess it will be easier to follow where things are. But that was really just to give you a bit of background. And as you'll see, that the latest versions of Singularity, I think the original Singularity project there at something like 3.8.5, and I know that I think Scilabs Singularity Community Edition is now 3.9 point something, the latest version. But you'll see when we go on to ARCHER2 that we're using, I think, version 3.7.3. So it's a slightly earlier version. And it's not uncommon, especially on large HPC infrastructure, that you won't likely see the very latest version in use because obviously it takes time for the platforms to test and deploy the versions and to updating them. It's not something that's probably done every time a new version comes out. There needs to be some time to test the new versions and to check that everything works on these large scale platforms. So I think that's probably everything for that sort of general introduction and summary. We will, for part one of this material, be working on the remote platform ARCHER2 that you've been given access to for the course. So I think this is probably a good time now to take a quick pause and see where people are at in terms of being able to access ARCHER2. There is an alternative here. If you happen to have your access to a machine yourself that has Singularity installed, you're welcome to use that for this part of the course. If you have a different version of Singularity installed to the version that we're using in the material here, you may see different behavior, or you may see things that don't work quite as you expect. That's something that we can, if you are in that position, we can offer some assistance as far as possible. Obviously, if you're working on a remote platform, there are limits to what we can do there, but we can certainly try and offer assistance if you're finding that you're getting different output. I think probably, so as I say, I think we'll take a short pause here. I can see that we've got a number of people who have been able to successfully sign in, but we've also got a couple of people who haven't, and a few people who haven't yet responded. So as I say, if you are working on a platform that is your own laptop or desktop or on another remote platform, that is fine, and you can continue with the material on that system. But if you don't have another platform with Singularity installed to use, then obviously you'll need to work on ARCHER2. And in fact, I think we recommend, if you do have an ARCHER2 account, if you've been able to sign in using the instructions that we provided, it's probably best for the first part of the course to use that. So I'm just going to take a pause for a couple of minutes and just see where we are. Do the helpers? I think everything's. I'm just checking the chat here to see where we're at. So we've got about 5 people still to respond. So don't worry about trying to run Singularity itself at the moment. If anybody is not able to sign into ARCHER2, that's the main issue at the moment. So if you're able to sign in and get a terminal, that's absolutely fine. I can see there's some people trying using the module commands and whatever. So we're at 20 past 10. We'll just give it about 5 minutes to make sure that people are up to speed, and then any problems that are remaining, we can look at in the coffee break. So we'll just take a sort of 5-minute interlude while we see whether people are having issues, and I will try and answer any questions in the chat as well. If anybody's got any questions at this stage, you're very welcome to unmute and ask questions. I'm just reviewing the chat to see where we are. Yeah, so just to be clear, that if you can sign into ARCHER2, Singularity is then available to you. There's nothing else that you need to do. You don't need to load a module. You don't need to install anything. As long as you can sign in and get terminal access, then you should be good to go with the next section. So there's a question there about even though you need admin access to install Singularity, to use it, the daemon does not require admin access as Docker. So in fact, one of the points that I made around the architecture of Singularity is it doesn't actually have a daemon in the same way as Docker. So there isn't a kind of core process that is running on the system, and that's actually one of the reasons why it's more suited to the platforms. So there is a kind of core Singularity executable that provides all of the functionality, and that executable is set up in such a way that it does have, from the way that it's installed, and this is why it needs to be installed by a system administrator, it does have some elevated privileges, and when it runs, it basically does what it needs to do with those elevated privileges, and then drops the privileges and goes back to being a sort of standard user level application, and that's why it's more suited to this sort of platform. I'm just looking if there's any other questions there. So I think we've still got a couple of people who are having problems. So if you originally pressed no on the poll, but you're now okay, if you can switch to yes, that would be useful. But I don't know whether I've got a couple of people who are still having issues. So I'll give it another couple of minutes. I think if there are people who are having problems that need more assistance, then we'll obviously have time in the break to look at that. And so there's a question there about yeah, if you got disconnected. So we're literally at this point in time just going through the process of getting people to sign in to ARCHER2. So the details of that are in the setup, and I will show you in a moment. I'll go through. So let me in fact do that on my terminal now, while we're just waiting for anybody else to get things resolved. So if you so let me go back to So here you can see my terminal. I'm actually in ARCHER2. I'll create a separate connection. So that's my username. So what I'm going to do is, just bear with me for 1 second. I'm just going to take a separate terminal across here, and what I'll do is I'll just show you the process of signing in. So if you've got a
Jeremy, yours. Oh yeah, it's okay. It's okay. No, it's fine. I'm just being stupid.
No, it's all right. I was just copying and pasting something from my So right, okay. So what you'll need to do if you want to sign into ARCHER2, I'm going to exit out of here, and I will create a new connection to show you. So we're using SSH. So I'm going to do SSH. I'm going to put in -i. This tells SSH the key file that I'm going to use for ARCHER2. So this is a key file that I have stored in my home directory. So tilde is my home directory, the .sh folder of my home directory, and then the name of the key file. So that just happens to be the name of the key file that I've used. So I'm saying SSH, so secure shell connection to ARCHER2 to a platform using this key. The username that I'm connecting with is this username, and the platform that I'm connecting to, the domain name is login.archer2.ac.uk. So that's what my command looks like. And when I hit enter, firstly, I'm getting asked for the password for my key. If you're using something like SSH agent on your system, if you don't know what that is, that's not a problem. But if you are familiar with that, you may not see this passphrase request for a key because it may have been stored. I'm typing in my password. Oops, and I've obviously typed it incorrectly. Right, so this time I typed it correctly. So that's now unlocked my key. And what I'm now getting is a password prompt from ARCHER2 asking me for my login password in ARCHER2. So I'm going to type that. And then I get a login. In fact, it's the terminal there's gone a bit, if I make it a bit wider, you can see the thing. So that's the process of logging in. For any of you who are familiar with SSH and know that know the existence of the SSH config file, if you're not, that's not a problem. You can actually put something into the config file so that you don't have to type that long command line every time. So in fact, what I do on my machine normally, I'm going to exit out again, is I just type SSH ARCHER2, and I have an entry in my config file that tells SSH when I ask to get SSH to ARCHER2 the domain name that it's got to connect to and the name of the key file, so I don't have to type that all every time. So when I type that, I get exactly the same we saw before. Okay, so that's the process of signing in. Do we still have anybody who is having issues signing in? In the interest of time, I'm going to move on, but I know the helpers are on hand and will provide further assistance. We're just going to do some initial kind of basic checks on Singularity on the system and show you how to check the version and to do some basic processes with it. So it should be possible for anybody who is just still getting things sorted to catch up. But I will move on if that's okay. And as I say, do feel free to put your hand up and ask questions as we go along. If you've got anything that you want to ask, I'm going to close the poll for now. I can see the vast majority of people seem to be ready to move on, I think. So I'll close the poll, and any problems, the helpers will continue to assist, and feel free to ask questions, and there'll be some time when we get to the first break to resolve any more substantial problems. Okay, right, so just turn my video back on. Right, so we have a shell here on ARCHER2, and there's a note here about modules. I know some people were putting questions about that in the chat. So this is just highlighting that on many HPC systems, there is a module system where multiple different versions of software can be present. And what you normally do is load the module to set things up for the piece of software that you want. So you might type something like module load Singularity. On ARCHER2, that's not necessary. It's there in the standard path of the system when you sign in. So you don't need to worry about that on here. But this is just here because this is designed to be where possible, generic material that will suit other systems as well. So it's just highlighting that. In the case of ARCHER2, as I say, we don't need that. And so what we can do to check what version we're running is you should now find that you can type Singularity --version at the command line. And if you're also working on ARCHER2, you should see that it's 3.7.3-1. If you are working on a different platform, you may possibly see, or you quite likely will see a different version, I suspect. But that shouldn't be a major problem. If you are on a version of 3.7 or above, or even 3.5.3 or above, you should be able to follow along with the material here. Okay, so we talked yesterday quite a bit about images and containers, and I thought I'd just give a quick kind of review of what we mean in terms of terminology with some of these terms, just to really to clarify as I go through what I'm talking about when I talk about images and containers. So the definition that we're using here is images are bundles of files that include an operating system, software, and potentially data. So it's a big kind of set of all of these files bundled together into an image, and it's sometimes referred to as a disk image or a container image. And there are different ways that they can be stored. Sometimes it's stored just as a single file, so it's effectively one file that contains all of this stuff inside it. Sometimes they're stored as a group of files, but either way, this is referred to as an image. And a container, on the other hand, is a virtual environment that is based on an image. So you can think of an image as a bit like a sort of template, and then you can create containers from that. So the container is the running entity that's created from an image, and you can create multiple containers from one single image. So you can have an image and you can fire up as many containers as you want. The image is kind of the basis from which the container is created, and we saw this yesterday with Docker, and I hope that is fairly clear to people. But I just wanted to clarify the terminology here before we go on. So when we talk about a container, and this obviously goes as much for Docker as it does for Singularity, as we saw yesterday, we're talking about the kind of running environment that is based on some image. And the image itself is just the files that are stored containing the kind of configuration and applications that make up the environment that is created when you run the container. So what we're going to do now is we're going to look at the most basic thing we can do with Singularity, which is to run a very simple container. So if you recall, when we looked at Docker yesterday, we particularly saw this when we were actually getting to the point of creating the Docker containers, creating Docker images. We looked at how the images are created as a set of layers, and we saw that often when you pull a Docker image from Docker Hub, you see these different layers being downloaded. You often see sort of several things coming. You see it downloading each one in turn. And within Docker on your local system, you have a kind of local Docker repository, and we saw how you can type commands like docker image ls, and you can then see all the images that are stored on your system. And so in the case of Docker, the images, the files that are downloaded for images are effectively managed by Docker itself. So when you pull an image from Docker Hub, you don't end up with a file sitting in your directory that is that image. The image kind of goes off into the Docker system, and you can see that it's there by doing docker image ls, and you can create containers from it, so on. But you don't actually have, the files are obviously on your system, but you don't have direct access to them unless you specifically were to go looking for how it was stored. The way you interact with them is not by working with the image files yourself, it's by interacting with the Docker daemon, the Docker system, using the Docker command. So Singularity images are a little different to that. Singularity uses, there are some different formats, but the core format that's used is the Singularity image format, and images are provided as single files, so SIF files, Singularity image format files, with a .sif extension. And you can pull images from, as we'll see, from Singularity Hub, which is a kind of similar repository to Docker Hub. And what you get is, unlike Docker, where this goes off into the Docker repository on your system, you actually get the image file pulled down onto your system. It is just a .sif file that ends up in the location where you currently are on the system. We'll see all this in a moment. And so that's a kind of fundamental difference from how things work with Docker. And I should also highlight that Singularity has developed a long way, and it's now possible to pull images also from Docker Hub and from some other sources. And we'll look at that a little bit later in the material, how that works. So I mentioned Singularity Hub, and this is a repository. It's an image repository for storing Singularity images. You can browse the images by looking at the website. So I mean, if I just go and just open that in a separate tab, we can have a look. So it's somewhat, I guess it's somewhat simpler than Docker Hub, which was rather more advanced. You can see it's basically just a listing of all of these different directories with the images in them. But we don't specifically have to interact with this website. We can do everything through the Singularity command locally on our system. And as you'll see when we do that, it does look quite similar to how we worked with Docker Hub. So I'll close that for now. So this is kind of the first thing we're going to try, is to pull a very simple Singularity image. So on your terminal, on your ARCHER2 terminal, create a directory. I've called it test. You can call it whatever you want, but just sort of somewhere to work in. So I'm going to create this directory test. I'm going to go into that directory, and I'm going to pull from the Singularity Hub a simple hello world image. So I'm going to create my test directory. I hope that you can all see that. I wonder if I need to move it further up the screen, do let me know. I hope it's not cut off. I know sometimes if it's right at the bottom, it can cut off on the screen share. I hope everyone can see that. If it's going off the bottom, then do let me know. So I've created my test directory. In fact, what I'll do, just to avoid any issues, I'll just move that up slightly. So I'm going to cd into my test directory, and I'm now going to use the command that was shown here to pull the hello world image. So how does this work? So we say Singularity pull, and we then say the file name that we want the image to be stored as. So in fact, we can call this whatever we want. We don't actually have to call it hello world, but because that's the image that we're pulling, I'm using that name. So what we're saying is pull from we're going to pull into the file hello world.cif, so store it locally in the file hello world.cif, an image from Singularity Hub, and the image that we're going to pull is this particular image here. So this tells us it's from Singularity Hub. It's from this user in Singularity Hub. So this is, as you see, look very similar to what we saw with Docker. And this is the name of the image. So pull into this particular local file. This is where it's going to get stored. An image from Singularity Hub from this user, and the name of the image is hello world. Okay, so if we enter that, what you should now see is that we've seen here a message that's come from Singularity to say it's downloading a Singularity Hub image. We then saw the image actually getting downloaded, and it's completed. And if I now do an ls, what you'll see is that we've now got the image stored locally here. There's the file, and if we do an ls -l, you can see that it's a 60 megabyte file. It's a fairly small image, but it's not tiny. And that's our file that we've stored. So now we might want to actually run that. So it's all very well that we've got the image sitting there. We actually want to do something with it. So we're going to run a container from that image. So very similar to Docker. We can say Singularity run. In this case, we give it the actual file, so the file that's stored locally, and run, and it's given us this rather interesting output here. And that means that we have successfully run the image, and we've run a container from that image. So how do we know what actually just happened? So we ran it and we got this output, but where did that actually come from? What made it do that? So when you run a Singularity container from an image, Singularity images can have a kind of default run command built into them, and we saw this yesterday with Docker. So when you created your Dockerfile, you could put in either entry point or CMD to run something by default when the Docker container is run. Here, when you run a Singularity container from an image, the image can have embedded in it a kind of default run command, and that's what's been run here on the terminal. And to have a look at that, we can use the Singularity Inspect command. So if we run Singularity Inspect, -R to select we want to see the run command, and then the image file. So that's the file that we downloaded. We see that this is the little shell script that's embedded into the image, and when you run a container from it, that gets run as the default run command. So that hopefully gives you an idea of what's actually happened when you run that container, and that's really the sort of most basic use of Singularity. And I hope that hopefully most people have been able to get to that point and have been able to successfully run an initial image. So what I'll do now is I will move on to the next section to look at the Singularity Cache. Have we got any questions on that previous section? Does anybody? I can see there's a few questions in the chat, and the helpers are answering questions. So thank you to them for that. If anybody has any questions that you'd like to ask, feel free to put your hand up and ask. If not, we will move on with the Singularity section. I'll just give it a minute and see if anybody's got any questions. No? Okay. Excellent. All right, we shall proceed. So Singularity, Singularity's cache. So Singularity, as I said, doesn't have this local image repository the same as Docker. So when you pull your image, as we saw, it comes down as a file. It's not going off into this sort of central repository of images. But it does have a cache. And if you delete a local .sif image file that you've pulled from a remote repository, and then you pull it again, if it's not been changed, you won't download it again. So this is designed to ensure that effectively it saves some bandwidth of downloading things every time. So I can give you a demonstration of that. If we have a look here, so we've got our file hello-world.sif that we downloaded from Singularity Hub. So I'm going to delete that. So I'm using rm to delete it. If I now have a look at my directory, there. Okay, and I'm now going to run the Singularity pull. I was using my history there rather than typing out again. The Singularity pull command again. So what I'm saying here is, again, I want to pull into this image file the image from Singularity Hub. So what we'd expect is it goes off to Singularity Hub and pulls that image again. When I ran that, we didn't see it download this time. In fact, we just saw a message that says use cached image. And so the question is, what actually happened? Where did this cached image, as it's talking about, come from? So if I do an ls again, you can see the file is back. So what's actually happened there is that the Singularity has this cache stored locally. So every time we pull an image from Singularity Hub, it's coming down as a file, as we saw, into our local directory, but it's also getting stored somewhere else on the system in a cache. And that's where it retrieved the file from this time. And we can actually interact with that cache and find out what's going on there. So if we type Singularity cache list, you can see that there's one container file that's stored in the cache. It doesn't tell us very much about it at this point. It just tells us there's one of them, and that's the space used. I think that message is actually perhaps a little bit misleading, because I guess it's probably perhaps say there's one image file stored. But it's telling us that there's one image there, and it doesn't tell us very much else. But what we can do is use the -v switch to Singularity cache list to get a bit more information. So -v for verbose. And so there's a question there. Somebody saying didn't get use cached image. So yeah, I think that's if you didn't delete your image first, the image file is already there. So it will just tell you. So in fact, if I try to pull that again now, I'll probably get the same thing. So that's probably what you saw. So what it's telling me is the image file already exists. It's not going to overwrite it. So if I do an ls, we can see that the file is already there, and that's why it's not going to pull it again, because it's already there with that name. You can, of course, with a different name. So you could say,
Jeremy,
pull...
Brian has his hand up as well.
Oh, sorry, apologies. Sorry, I missed that. Yeah, go ahead, Brian.
So when you run Singularity cache list, it says there are one container files, and I was just a little bit confused because I thought the distinction was that it was pulling images because it's the Singularity image file.
Yes.
So it's yet, right? Or am I confusing the terminology here?
No, I think, as I just mentioned before, that I think that message is a little bit misleading. So I think it should say there's one image file It's not a running container that's stored. It is just an image file. So you're quite correct that I think it does slightly confuse the terminology, that message. It is to my mind, it's an image that's stored, not a container. It's an image file, and it is not. It's got nothing to do with a running container. What's stored? It's purely just an image file. So I think the message itself is perhaps a little bit misleading there.
Okay, thank you for clearing that up.
That's okay. So I was just going to show here that the file name that we give here. So although the image is called Hello World, the file name that we give, actually, we can choose whatever we want it to be. So we saw that when we tried to pull something that was already there, we got this message saying image file already exists. If I called it hello world2.sif, you'll see that it's now downloaded it from the cache again. And if I have a look now, I've got two image files that are both identical, but I chose a separate name, so I didn't get the error saying it was overwritten. So the name is not specific to the name that comes from the Singularity Hub. It's just a file name that you can choose. You can call it whatever you want. But it knew that this image was already stored in my cache, even when I called it a different name, and it's then just pulled it from the cache. So I hope that was clear. That was just to clarify the point that was made before about the error. So I'm going to get rid of the hello world 2. I don't need that. So what we were just looking at was we did a Singularity Cache list and saw this message, which I think agree is a little bit misleading. It should really say image file, but we can't see very much information there. So if we use Singularity Cache list -v for verbose, we get a little bit more information provided. So what we can see here is we get the original message telling us how much space is being taken up, but we can also now see some further information. So what we can see here is there's an image. It's been given some kind of unique ID for the name, and we can see when it was created, and we can see how big it is and where it's from. The type of the image is a Singularity Hub image. So that's the cache and the storage of the files. You can clean out the cache. So as we saw at the moment, if I remove the hello world.sif file from here, and I then try and pull the image again, it's always going to pull it from the cache because it's stored there. If I want to empty the cache, I can say Singularity Cache clean. And I then get this message telling me it's going to delete everything in my cache. So I have to be a little bit careful here. In this case, I've only got one image in the cache, so it doesn't really matter. But of course, if you've been pulling very large images, so say you had a multi-gigabyte image sitting in your cache that might have taken you some time to download, you might want to be a little bit careful before deleting everything from the cache, because you might lose something that would then take you a significant amount of time and bandwidth to download again. In this case, that's fine. I know that I've only got one thing there, and I'm happy to remove it, so I'm going to say yes. And it gives me a bunch of output, which we'll look at in a little more detail in a moment. But we can see that it's removed one entry from the cache. So there's a question there whether the cache version and the CIF file are the same thing. So yes, they are. It basically the thing that was downloaded was stored into two places. It was stored into our local directory with the name that we gave it, and then it was stored into the cache directory. And we'll look in a moment where you can find that. But rather than being called hello world.sif, it was given this kind of long unique ID name. But it is basically the same. Maybe the same is not the. They're two copies of the same thing. So it's not the same physical file. There is actually a separate copy of the file stored in the cache with a different name, but it is the same content. And there's a question there: if you have the CIF file and you clean the cache, can you still run the file? Yes, you can. So I can show you that. If I, in fact, I can't because I've just emptied the cache. So we'll start again. So in fact, no, I can show you that. We've emptied the cache. So if I do Singularity Cache list, you'll see that the cache is now empty, but the file is still in my local directory, the CIF file that I previously downloaded. So emptying the cache has not deleted the local file. It has no bearing on that at all. And I can still run that locally. So I still have this image sitting in my local directory. It's not cached, so if I tried to pull it again, it'll have to download it again. But at the moment, I don't need to pull it again. I've got the original file here, and I can indeed just say Singularity run world.sif, and it runs. So although the cache is empty, I've retained my local copy, and I can still run it. So hopefully that answers the question there. Okay, so we've seen that there is this thing called the cache. We've seen that we can look at what's in it. We've seen that we can clean it. You may still be wondering where the files are actually stored. And in fact, we got a bit of a hint to that here. When we emptied the cache, we got a bunch of output. And you can actually see that the location, the default location for the cache is in your home directory in a directory called .singularity/cache. And that's where it stores the files. There's a question there whether it's possible to clean specific files in the cache. Yes is the answer. There are different options. So you can certainly clean different types of files. So as you can see here, there was a bunch of different directories that it went through: blob, library, etc. These are different types of images. So if we look in, so if I look at my home directory, if I do it like this, so you can see. If I look in home.singularity, in fact, because I cleaned the cache, I don't think it's actually there. Oh, it is there. Sorry, that's something that didn't work with the home there. So that's the directory home Singularity cache, and you can see these are the kind of the subdirectories in there. Maybe if I use -L, it's a bit easier to see. So you can see that these are all directories, and these are directories of the different types of files. So you can clear the cache by file type. So if you wanted to get rid of all of the things that have come from Singularity Hub, you can tell it to remove all of the shub images, and you can use there's a help command. If I look at Singularity Cache -help, so Singularity Cache clean -help, you'll see that there's the options here to set various different things. So you can set to remove only things that are older than a certain number of days. You can tell it to remove the particular type using -t. So if you, for example, were to say Singularity Cache clean -t and then shub, it will remove only the things that are installed in the cache that come from Singularity Hub, but other ones will be left. You can't, I think, remove an individual file by name because they're all given these unique IDs. You could just go and manually delete the file, but there's probably not really a lot of reason that you'd want to do that unless you've got a particularly large file in there that you don't want. So I'm not 100% sure, but I don't think there's a way to remove an individual cache item rather than other than going and manually deleting it from the cache directory, which you can of course do if you wanted to. Okay, so I hope that gives you a bit of idea. So there's a question there about the size. As far as I'm aware, it's pretty simplistic, and I think basically it will just use whatever space is available. I'm not sure that there are built-in quota options. I think the way you would probably normally do that is you might a file system of a particular size and then allocate that to the cache directory. So you'd manage it at the kind of the operating system level rather than through Singularity itself. I don't think that there's any sort of quota capabilities built into the Singularity Cache command itself. Okay, so that's the Singularity Cache. If there are any questions, I'm happy to take questions on that. Otherwise, we'll move on to the next section. So there's a question there about whether there's a benefit in using the cache rather than using a CIF file that you've downloaded some other way. So the answer is no. So basically, the cache is consuming extra space. So if I download an image from Singularity Hub and it goes into the cache, and then I've got the file that's locally in my directory, I've effectively got 2 copies of that data. So I'm actually using double the disk space. The benefit, obviously, of that is that then if you remove the image, if you've got some workflow where you're pulling the image into a particular location and then using it and then deleting it, you don't have to keep downloading it. So the benefit of the cache is, from my understanding, the bandwidth that you save from having to download things multiple times, but it's not saving you in any way on disk space. In fact, it's using more disk space than if you just pulled a CIF file using some other means. Hopefully that answers the question. Okay, I think that answers any questions that were in the chat. So we'll move on to the next section. Okay, so now we get into stuff that's getting us a little bit more towards what we saw with Docker and some of the kind of options that were provided there. So we're going to look at how to run specific commands within a container. So we've got our hello world image here, and we saw that if we just ran it with, I'm going back through the history, it's probably not worth it, it's probably easier to type this again. If we just run it Singularity run hello world.sif, we get the standard output, and we saw that we could see what that was by using Singularity Inspect and looking at the run command, and that's the default run command for that. So that's what's run that's caused it to print that out. So we saw that earlier on, but what if we want to run other stuff? So the other option is that there is a Singularity Exec command. So rather than using Singularity run and having it run the default run script, we can use Singularity Exec, and we can then put at the end of the command the thing we want to run. We obviously have to know that the command that we're running, so in this case, with the example here is to use bin echo, we have to know that the command bin echo exists within the image. In this case, it's a standard system command, so we could expect that that's the case. So if we were to run Singularity Exec, then we give it the image file, and then we say the command that we want to run. So we're going to start off a container from that image, and we're going to run a particular command. And the command that we're going to run is bin echo hello world. And we run that. And what we can see this time is that it didn't run the default command that it ran previously. So we didn't get this output that we saw previously. Instead, we got the output hello world, and that's come from it running this command that we told it to run. So that's how we run a specific command within the container. We can see that the Singularity, using Singularity Exec, we've completely bypassed the original run script that was stored within the image. So the run script is still present, but we've bypassed it entirely. And we saw yesterday with Docker that we could do similar things with the ---- entry point command, which I think we looked at yesterday. So this is a kind of similar example to that. So just a brief exercise for you. So you've seen there how to use Singularity Exec to run something. How might you run a container from the hello world image and get it to print the current date and time? So if you're a Linux or a Unix user, that may seem obvious to you, but if not, that may not be immediately obvious. But if you have a think about that, I don't know if some of you might know the command that you run to get it to print the current date and time, but do have a go if you think you know the answer to that. We'll give it a minute or so for you to have a play around with it, and then I'll look at the answer there. In the meantime, if there are any questions, feel free to put up your hand or to put a question into the chat. So there's a question there about why write bin echo instead of just echo. So in this case, we're just being explicit with the command. It depends what the path is that's set within the image configuration. So in this case, if I was just to run echo hello world, it does work because echo is in the path within. So when the container is spun up from the image, there is a path set up in there, and it does correctly run. But the reason I used bin echo in the example there was really just to be explicit about what we're actually running. We're running the echo file that's in the bin directory. So that's was just for clarity, really. But yes, you can run it without. So somebody's put in the chat there that you run the date command at the end of exec. So yes, for those of you who tried that, you will see that will have worked. So if we run Singularity Exec hello world.sif and we say bin date, you'll see that we get the current time. So bin date is a sort of standard Linux command that will give you an output that looks something like this, telling you what the current date and time is. So yeah, that's the answer there. So you can see you can basically print out any, you can run any command using Singularity Exec if the command exists within the image. Okay, so just to finalize that section and just to be very clear on that point, the difference between run and exec, if you use run, that will run the default run command set within the container, and if you use exec, then you provide the command that you want it to run, and providing that command is found within the image, it will run. So the question there, how do you check which commands are available within the container? probably the answer to that is there's not an easy way to do it. You need to know what's within the container. So if you've packaged a container, if you've packaged an image yourself, then you will know what you've put in there. If you're using an existing image, then I mean, with standard Linux commands, you can assume that if, for example, it's a basic Ubuntu image or a basic Alpine image, these distributions have the standard sets of commands that you normally find present. But obviously, if you're looking for something with some specialist software in there, then you'd have to be getting a container that's actually got that. You could do an ls, that's entirely correct. So there's a message there. So you could run a container from the image and actually do a list of what's in there. But there's no way of getting a sort of some kind of directory of everything that's in there, I don't think, without using commands like that. So there's no kind of metadata, I think is what I'm saying, that tells you what's within an image. You can only find it by actually looking at the content through some other means. Hopefully that answers the question. I think that's correct. If anybody else has got a better way of finding that out, please do put something in the chat. Yeah, so there's another suggestion there from Andy that you could use the which command to see if something is actually present. Okay, so the other way you can, of course, do this, and the other way so there is actually, so that's a good point. You can get some metadata if you use inspect without the, so let's actually just quickly look at that before we move on. If you use inspect without the -r, it will give you a bunch of metadata about the container. So about the image, sorry. So that's telling us just some very basic metadata. It tells us what the kind of full size of the image is. Tells us some things about the version and what the base distribution of the images. So in this case, it's Ubuntu 14.04 Linux is the base distribution, and the version of Singularity that it was created with. I wonder if there might be something where we can get some more information there. I think there's a verbose option where we can get some more data. So I wonder actually whether, so there's a whole bunch of options here. There's, for example, there's list apps. I'm not sure whether that's using some metadata that we will not have present here. Yes, I think it probably does. So there's a whole bunch of stuff here that you can look at in the help for the inspect command. If we use -all, you'll find a little bit more. That's kind of the more verbose option, I think. That's going to give us a whole bunch of additional metadata there. In fact, it's mostly what we saw before, but there's a bit of extra stuff that we can see what the run script is. So that was when we used -r. It basically gave us that particular piece of content. We can see here the definition file. So this is the content that was used to actually build the image. We're going to look at definition files a little bit more later on. So yeah, there's ways to get some various metadata out, but none of that is telling us kind of exactly what's inside the container. Sorry, what's inside the image. The best way to do that otherwise is to run a container from it and go and look at what's inside. So let's go back to the material, and so we were looking at how to open an interactive shell within a container as the next thing, and we can use the Singularity shell command for that. So we can run Singularity shell hello world, and we get the Singularity prompt. This is really just to show us that we're inside a container. It's just really a standard shell still. So if we were to do ls, we can see. So this is something very interesting. We can see at the moment that we have our file hello world.sif. We're actually in a container created from that file, but we can see the file itself locally. We'll have a look in a moment at what's happening there. But if we were to look at, for example, /bin, as was suggested before, you can see there all of the kind of core system commands that are stored within the that are accessible in this container that we've started from the hello world image. Is there a question in the chat there? No. Okay. So this is something then that we're gonna go into now. What we just saw with the container. What do you? There's a couple of questions for discussion here. What do you notice about the output of the above commands that are entered within the shell? So what we did here was, if we go back and just show you. So I've started my shell, and I'm going to do a who am I, and I can see that actually I'm my user from ARCHER2. So that's something we'll look into in a second. And if I did ls, we saw that we had the hello world image as well. So the question is, what do we see from that? What's interesting about that, and how does this differ from what you might see within Docker? So if you think back to when we went into a shell in a Docker container yesterday, what would you have seen if you'd done a who am I within the Docker container? Does anybody have any thoughts on how this might differ from what we would have seen within Docker? So there's a couple of suggestions there. So somebody suggested root. So yeah, that's correct. So if you did a who am I in the Docker container, I think you would see root, and that's because you would be the root user inside the container. Now here, I'm not the root user. I'm my own user from ARCHER2, and okay, that's at one level seems kind of reasonable. We've already talked about the fact that Singularity doesn't have the kind of root privileges that you get from Docker because of the way that it's developed. So you tend to work within your own user environment. So that kind of makes sense. But actually, it's a little bit more complicated than that. And we're going to look into that in a minute in a bit more detail. But just to say at this point that, yes, it's correct that we are our user from ARCHER2 within the Singularity container. And that's actually not as straightforward to provide as it might initially seem, and we'll look at why in a moment. And the other thing that we saw was indeed that we were in the directory which has hello world.sif in it, which looked remarkably like the directory we were in before we started the container. And if we do a pwd, we actually see that the directory we're in looks to be the directory where we started the container from on ARCHER2. And so there's a question about how is that directory from ARCHER2 seemingly also inside the container that we've run. And we're going to look at that in a little bit more detail in the next section. So what we've done here is we've looked at how to use the exec command to run an alternative to what's configured by default within the Singularity default run command within an image. And we've also looked at how we can get into a shell using the Singularity shell command. In the next section, we're going to go on, so I'll just skip over that part with the break. We're going to go on to look at files in Singularity containers, and we're going to explore in a little bit more detail what's happened here inside the container when we started the container within a shell, and how it is the case that we seem to be our own user, and how we seem to be in the same directory that we were in on the host system. And that relates to how Singularity handles files and the way that it's configured on startup to set up your kind of user environment. We've been going for just over an hour. I wonder whether it's worth us making a short start on this section, or whether we should maybe take a 15-minute break now and then come back and carry on with the files and Singularity containers section. I'm just thinking about what's the best option. I think maybe we'll just work through for another kind of 10 minutes, because we've got then another kind of hour and a half to go. So if we take we'll work through this section for a few minutes, and then we'll take a 15-minute break, and then we'll come back, and we're planning to do lunch around about 12:30 to 12:40. So that should work out just about right. So we'll just do another few minutes to look through this, and then we will go for have a 15-minute break. So there's a question there about whether the file. Okay, so that's interesting. I noticed that somebody there has put in a message that they seem to have lost the SIF file. Now I wonder if that's because, did you have the SIF file in a test directory, or was it in your actual home directory? It looks like probably didn't. So I'm not quite sure what's going on there. We'd have to have a look at that. Maybe that's something we have a quick look at in the break.
So.
Sorry, Andy, go ahead. Is that
yeah, I was going to say, I mean, it depends where you have the original SIF file. So yeah. Because Singularity mounts your home directory by default, but not other directories. Yeah, so for example, so Elliot, you're there in I can see from the first line of your output, you're in the work directory there. Okay, so that isn't mounted. Yes. That isn't mounted by default. Your home directory is. So when you start the Singularity container, the directory you were in doesn't exist, so it drops you back into your home. It drops you back into your home directory by default, which is available. So you'd have to actually bind mount your working directory, your current working directory, in if you're not in your home directory already to be able to see it within the container.
Yeah, thanks, Andy. Sorry, I missed it. Yes, indeed, you've got. I can see there now that you're in work where you have your image not in your home directory. So yeah, as we'll look at in a minute, the directory that's mounted by default is your home directory. And in fact, the reason that so I was working specifically in home, and then in a test directory within that, so that would be mounted by default. We'll look at how to do bind mounts of other directories in a little bit. So there's a question there: when raw.sh was added to /, was it only possible because the container gives you admin? Yes. So yeah, that's a really good question. When the image was first created, the files that were put in there in a kind of root environment. So the image was built by somebody who had root access on the system where they built it, and they were able to put all those files in. So that's quite correct. And as we'll see when we look into this in a little more detail, and in fact I can show you that here, if I do an ls-l of the root directory, what we actually see is that all of the files that are in that location are actually owned by root. And as we'll see in a minute when we go into that, we can't edit those files. So although this is a container that we started from an image that we downloaded, we don't have complete and utter flexibility in what we do with it. If we were working in Docker, as was highlighted before, we would have root access. We would be root by default, and therefore we could do whatever we wanted with the files inside the running container. In this case, we can't do that because there are files there that have root ownership, and we don't have root access because we have our own user privileges based on the user that we are on the host system. So we'll come to look at that now. Okay, so we've seen the basics of how to start a container from an image, and we've seen that there's some interesting stuff going on here with how the accounts and the permissions and whatever are handled that differ quite significantly from what we saw with Docker. So when we are running a Singularity container, this just reiterates what I was just saying, really. We only have the same permissions to access files as the user that we had on the host system. So I'm working there on ARCHER2. I only have the same permissions within the container to access files as I would have on the ARCHER2 system. So the example here being that anything that's owned by root inside the running container, I don't have access to do anything with it because I don't have root privileges. So I've started this container and I can see all of these files, but I can't necessarily edit them or delete them or whatever. And we're going to look here in this section about working with files and how some of these things work. So we saw before that when I ran the whoami command, I saw the username that I was signed in on ARCHER2 with. So just to repeat that, in fact we saw it on the command above, I'm seeing that user, my ARCHER2 user. But since I downloaded a public image, so I downloaded a public image hello-world.sif from the Singularity Hub, and I haven't customized it in any way. I've just run it. I haven't changed anything else. I've just run a container from it. How does it know who I am? How is it configured with my own user details? Now, if you have any familiarity with Linux system administration, you might be familiar with the etc. password and etc. group files. And in Linux, those are the files where account and group information is stored. So for those of you who are not familiar with this, in Linux, you have a username and a group. So here is my username, and all files that are listed when you do an ls-l, when you do a long list, show you the file, the ownership of the file based on the user who owns it and the group. So here we can see that I have the home directory within the running container, and it's owned by my user and my group, which is in fact the group that's been set up for the course. And the files, etc. password and etc. group are the files that contain the details that provide the user and group information. So in order for the shell within this container, I'm sitting at a shell inside my Singularity container, in order for it to know who I am, my user from ARCHER2 and my group from ARCHER2, it needs to have this information within these files. And so you might ask, well, if I've just downloaded a public image from somewhere that knows nothing about my user on ARCHER2, and in fact knows nothing about ARCHER2, how has it got this information in those files? So the answer to that is that assuming that Singularity on the system, this is the case on ARCHER2, and it's likely to be the case on most other systems, but it is configurable. But assuming that you have this kind of standard configuration for Singularity, what Singularity is doing when you run your container from an image is, behind the scenes, it's actually adding kind of dynamically into the files within the image your user details from the host system. So when I run the Singularity container, what's actually happening is that the Singularity system, the Singularity command that I'm running, is getting my current user, getting my current group from the host system, from ARCHER2, and it's putting those into the relevant files inside the image. And this means that I can then, when I'm in the container, have effectively the same permissions that I have on the host system. So it's a way that ensures that I basically have only the permissions that I have on the host system, and I can't do anything with files that are in the container that I couldn't do on the host system. And the reasoning for this is that then if I was to bind mount a directory, and we'll look at that in a moment, if I was to bind mount some sort of directory or folder from the host system into my Singularity container, I wouldn't be able to do anything with it that I couldn't do on the host system. Whereas if I was in a Docker container, if I was to bind mount something where, for example, files were owned by root into my running container, I could theoretically have access to change those because I would have root within the container. I hope that makes some sense. But basically, this is done as a way to ensure that you're not given any kind of elevated privileges when you're inside your running container. And this is one of the reasons that Singularity is considered to be more practical for working on these kind of shared platforms. Okay, so there's a question in the chat there. So just to address the question in the chat, I think this is going back to what we were looking at before with the sh file that runs when you. So if we just look, I can just demonstrate this quickly here. So we have this raw.sh file that's sitting in the image, and it's then visible in the container that we've run from that image. And the question is, why did you need admin privileges on the host? So the point is, here we've got a bunch of files that are owned by root. So when this container was built, the person who built this container, when the original image was built, the person who built the image needed to have root permissions in order to create files that are owned by root. And so the fact that this file here is owned by root means that the file had to be created by a user who had root permissions. And in fact, as has been pointed out in the chat there, because we're looking here at the sort of slash directory, the root directory of the image, or in this case, the files that we see in the running container. Basically, on a Linux system, all of the files in the slash directory are kind of the base system files that have been created at the time that the system has been set up, and they therefore are owned by the root user. So they're kind of, they're basically files that are, or the directories there, many of the directories, the standard approach in Linux, or the convention is that those directories that we see, such as bin and opt, etc., whatever, would be owned by root, because they are kind of core system directories that are created at the time when the system is set up. Hopefully that makes some sense. Okay, so we'll break in a moment, but I'd just like to get through this little section here before we do. So I'll just finish this section on files and directories, and then we'll take a break. So we've looked at this idea that our user is visible within the container, and we've looked at how that's happened by Singularity being able to actually take some stuff from the host system where we're running and put that inside the relevant places inside the image. And then when the container is run, we have our own user permissions. But But there's some more general things that happen. So Singularity is also binding some directories from the host system where you're running the Singularity command into the container that you're starting. So we can also see that we appear to be in our home directory. So if I do a pwd, I can see that that directory that I've highlighted there is my home directory on ARCHER2. And what's effectively happened is that that directory has been bind mounted into the Singularity container when I've run it. And again, as we know, the container does not have a directory with this name inside it because the container knows nothing about my user and it knows nothing about ARCHER2 to start with. The image that we've based the container on didn't know anything about this directory. So that directory has been created dynamically when we started the container. And that's basically being bind mounted into the container. So we can see if we look at this little diagram here, this is an illustration of what's actually happening. So we have our Singularity container that's running, and this is coming from an image which has this basic structure. So it's got a root directory / it's got a bin and an etc directory and user sbin, a bunch of other directories. And on the host system on ARCHER2, we've got a similar set of directories, but we've got our group file in there and our password file, which have our user information in them because we have a user account on ARCHER2. So as I explained before, what's happening is that the relevant parts of those files, so it's effectively one line from each of those files that relates to our group and our user, is being added into those relevant files in the image when the container is started. And the home directory that we have on ARCHER2 is being bind mounted into, again, a location that matches the location on the host system within the running container. So it's perhaps a little bit complicated if you're not familiar with the concepts, but the point here is just to show that there is some stuff happening behind the scenes that means that there's some sort of clever stuff that can be done to ensure that we have permissions that we have on the host system. So while the image itself that we took off of Singularity Hub is a sort of standard image that knows nothing about our user or our system we're running on, by doing these little changes when the container is started from the image, we can ensure that that we are in an environment that has the same permissions as we have on the host system. So there's a couple of questions there, and you perhaps want to think about these, and I'll come back and look at the answers after the break. But there's a question here about what do you notice about the ownership of files in the container that are started, and I think we looked at this in terms of the files being owned by root there. We could see that in the example that I showed in the terminal. And if you look at the file, the /raw.sh file, there's an exercise here to have a look at whether you can edit that file. And it suggests that you use VI, which is a common editor. If you're not familiar with VI, it's quite easy to get stuck in the editor. There's a link there to a quick reference for VI if you get stuck and you want to know what the sort of basic commands are. And the other exercise there is within your home directory within the container shell, try creating a simple text file. Can you create a file? If you can't, can you think why not? If you can successfully create a file, what happens when you exit the shell and the container shuts down? What's happened to that file? So a couple of things to think about, and I'll come back and look at the answers to those afterwards. So it's 11:22. We'll take just under 15 minutes break, so we'll come back at 11:35, I think, and we'll continue then. So I will stick around for 5 minutes if there are any questions, but feel free to go off and stretch your legs, go grab a drink, whatever, and we'll continue at 11:35. So do feel free to unmute if you've got questions or to put questions in the chat, and I'm happy to answer anything there. So there's a question in the chat there about Singularity Hub, and somebody saying that it redirects to this datasets datalad.org site. So what's actually happening there is the Singularity Hub, I think, fairly recently changed to use this tool datalad as the basis for the repository. So I suspect what's actually happening there, and I can have a look on my screen here. So if we just go to Singularity Hub, have I got it in my there? Maybe not. Let me just go to the. I thought I had it open here. Singularity Hub. You can, if you want to. So as you pointed out, yes, it redirects to the HTTP version of the datalad repository, but you can also just put an HTTPS in front of it. There is it is possible to make a secure connection to it. I'm not quite sure why the Singularity Hub redirects to that particular version. It might possibly be that it's I don't know if you go to Singularity Hub with HTTPS, whether that redirects to the HTTPS version. No, it doesn't. Okay, but yeah, but that is the correct site. The datalad site is the correct site for the Singularity Hub. As I say, it's recently moved across. I say recently, at some point, it's moved across to use this datalad tool rather than the previous system that was in use there. Lucy, go ahead. You got a question?
Oops. Hi, Jeremy. Sorry, I still don't. You probably saw my chat with Andrew back and forth. I think I'm still missing something. So, so when we start a container, does Singularity temporarily, so not create the image, I'm talking about what in the container, does Singularity temporarily need admin privileges at that point to move this the shell, the script, the in this case the raw.sh script to the home of the container?
No. So the container, the raw.sh file is already in the image.
It's already in the image. So when you spin up the container, you don't need.
So when you spin up the container, all that you're doing is basically creating a live instance of the content that's in that image. And the raw.sh file is already in the image at the location / with root permissions, because that's how it was created by the person who created the image. So you're not. So there is a. I don't know if Andy, you were gonna add something.
I was just going to say, yes, you can think of Singularity when you run it as briefly escalating your permissions to root to start up the container and then dropping it, but there's no moving of data. Right, the data appears as Jeremy said, as it was built into the image in the locations that they were built into the image.
Yeah. Okay. So
the reason that, if you think about, I mean, the raw.sh file in this case is not really the significant thing. The case where you would need some sort of admin privileges is where you have to change the etc. password and etc. group files, right? So those are the files that. So if I look at, I mean, I can show you an example. I don't know if you
because it needs them to know how to build the image. Oh no.
So if I look in the etc. group, as I'm just doing now, you can still see my screen share. I hope it's.
Yeah, you can.
Oh, I'm not quite sure why it's not actually doing that. It seems to be having an issue there.
I did follow because you spoke about that before, didn't you, Jeremy?
Oh, sorry. Okay. Yeah, no problem. Okay. Yeah.
There was just one comment in the chat that I just couldn't follow, but I'll think about it. I think we all should have a break.
Happy to go through.
What you keep on teaching, you must be tired. Okay.
It looks like my container has died for some reason here, so I'm not quite sure what's going on there. I'll investigate that in a minute. Let's, can I do anything to stop it? No, maybe not. No, okay, I'll.
This actually happened to me, Jeremy, earlier in the.
Oh really? Okay,
session.
right. I wondered if something.
I don't know what happened. It's exactly the same thing. I just had to restart a new terminal.
Right. Okay. Okay.
Okay. Thank you.
Okay, I'm just going to.
So I seem to be having some issues with the connectivity to ARCHER2. At first, okay. Yeah. So at first, I was able to enter commands. Yeah. Okay. Yeah, that's exactly what's happening to me.
So I'm having the same problem. So right, I've just noticed. So this looks like a connectivity problem, as you say, because what I was going to do was I think the network actually has gone. I think something's gone down actually with ARCHER2 because what I've just tried to do is open another terminal. Yeah. Open another connection to go and kill off the thing that was causing a problem, and I can't actually connect anymore. So I think the connection to ARCHER2 has actually just died. So it may be that it's just a temporary network.
It's not working for me either. I'm trying to find out what's going on.
Right. Okay. Well, so we picked, I think, a fairly good time to have a break in that case. Yes. Right. Login 4 is working. Okay.
Okay.
So, right. Okay. So we'll restart. I'm guessing everybody is back because we are a few minutes after the restart time. So if you're having any issues, for those of you that missed what was going on, there seems to be some sort of connectivity issue. One of the login nodes seems to be having problems on ARCHER2. So if you found that your connection cut off or got stuck, you should be able to connect to login node 4. So Andy's just put in the chat there a message with the host name, so login4.archer2.ac.uk. Hopefully everybody is able to connect to that. What I was going to do was just run through the solutions, or just look at the exercises from before. I guess what I'll do is just put a little poll up quickly, just to check everybody's okay before we. Let's just do that. See whether people are happy. Yeah, it's looking good. Okay, so I think it's looking. We've got no no's at the moment. So I'm hoping that people are okay. That's looking pretty good. Okay, so if there's any issues, please do again post messages in the chat, and somebody will help. But while you're just if anybody's trying to reconnect, I'll just go through this the answers to the exercises, and then we'll crack on with the next bit. So yeah, so what we looked at in the previous this section just before the break was we were looking at our hello world image, and let's get back to where we were before. So there's the place where we were, and we had the image running. So we'd done Singularity shell to start an interactive shell in a container based on that image, and we were looking at the fact that what we could see was our current directory, and we were looking at how we appeared to be our own user from ARCHER2 within the running container, and we seem to have this home directory mounted, and we looked at how that happens with the bind mounting, sort of automatic bind mounting. What the questions then asked were, what happens if you try to edit one of the files? So what you hopefully found if you tried this was, if we look in the / directory, we had this file raw.sh. If we were running in Docker, where we would be by default the root user, we would expect to be able to edit that file because we own the container that's running, and we're root, and we can edit stuff. The file is owned by root. It should be okay. What we will find here if we try to do that is if we use vi and we try to edit raw.sh, we can see the file, but we can also see at the bottom that it tells us that it's read-only, which doesn't look promising if we want to edit it. And if we were to try and do that, something in there, it tells us at the bottom we're changing a read-only file. If I then try to save that, it tells me I can't because the read-only option is set, and I should be able to override it with the exclamation mark. But if I try to do that, it tells me it can't open the file for writing. So it's clear that we can't write to that file. So as much as it's our container that we started from an image that we downloaded, we don't have complete flexibility to change everything in it because there's some stuff that's owned by root and our current user is not root and we don't have the permissions. So not able to do just what we want in that container. The other question there was if you're in your home directory within the container shell. So oops, I go, let's go up one level. So my home directory, that's my ARCHER2 home directory, but within the container shell. What happens if I try to create a file in there? So let's use vi again and create a file. And I'm going to put some text into the file, keep the hello world theme, and I'm going to save that. And I can now look there and I can see that I've got a file hello.txt that I just created. And the exercise asks what happens if you then exit the shell and the container shuts down. So we have been able to successfully create the file. If we then type exit to drop out, we're now back in ARCHER2 on the ARCHER2 login node. If I just go cd tilde to go back to my home directory, that was just one level up from where I was, and I do an ls there, see what looks like exactly the same thing as what we saw up here in the container itself. So we're in the same directory effectively. We're just seeing a view of that within the container before, and that file that we created inside the container is here. We can look at the content of it, definitely the same file, and we can see that the ownership of it is correct on ARCHER2. So it's actually being created within the container with our correct user and group ownership, which we can then access the file as normal when we go back onto ARCHER2. So hopefully that was clear. If there are any questions, please do feel free to put them into the chat. I'm going to close the poll now. I think there's one person there who seems to be having some problems. So if there's any assistance required, hopefully the helpers can provide some assistance with that. Let me just double check here and see. I think we're okay. So there's a question there in the chat. So yeah, so there's a question. Does that mean that processes running in the container can write data out to Scratch or Home or some other appropriate place? Yes, that's exactly right. So the fact that you are your own user within the container means that you can then write files to other locations with the caveat that you have to have had those directories made available inside the container. We'll look in just a second about how to do that with a bind mount. But yes, if you have access to directories on the host system inside your container, you can write files to them and they will have the correct permissions such that you can then read them when you drop out the container. Yes, hopefully that's okay. So I'm going to stop the poll, and if the helpers could just, if there's anybody there who needs assistance, right, put a message in there. Right, okay, so let's move on then to look at the binding of additional host system directories to the container. So we've seen that by default, we have this configuration where our home directory is available within the container, but sometimes we need to bind additional host system directories into a container that we're starting over and above those that are there by default. So for example, we may have a shared data set in some location on the host system, in the sort of shared location that isn't our home directory. and we might need access to that within our container. Perhaps we're going to do some computation using some software that's bundled up inside our container. And if that's the case, then we need some other way to make that directory available inside the running container. And we do that with a bind mount. And if you recall again from the Docker material yesterday, we used the --mount switch within Docker. And this is effectively the equivalent to that. The syntax is somewhat different, but it's basically doing the same thing in principle. So we're going to use the -b option, the -B, to the Singularity command. And that's the way that we specify additional binds of directories into the Singularity container. So, for example, you can see here, there's an example showing if you wanted to bind this particular work directory, so work Z19 shared directory into a container, you could use the command that's shown here. You could add the -b work Z19 shared to the Singularity shell command, and that would bind that directory into the running container when it started up. As is pointed out here, you're unlikely to have access to that specific directory, but I'll give you an example of how we can do that with a shared directory for our own course group. So if we take a look back at our terminal, we know that in our home directory, we are in this particular location, home TA049, etc. We also have a work directory. So when we run jobs on ARCHER2, and we'll see a little bit about this later, and this is the case in many HPC systems, the home directory is not available when you're running jobs. So compute nodes on the system. So for those of you not familiar with this kind of system, we've got some interactive nodes, one of which is what we're connected to at the moment, but we've also got a bunch of kind of hidden compute nodes that we don't manually log into. And when we run jobs on the system, they go off through the workload manager, and they are distributed out to the compute nodes to run. And in some cases, on some systems, compute nodes do not have access to certain directories that you can access on the interactive node. So for example, they may not have access to your home directory. And so the way that you work around that is that there are other locations given that are places that are used to provide files for running jobs. And in this case, we have the home directory where we can store our kind of home files, but which isn't available when we're running jobs on compute nodes. But we can access the work directory, and what you'll see here is that we have a kind of parallel directory structure that looks kind of similar to our home directory, but instead of beginning with home, it begins with work. So we can go to same directory prefix with work instead of home, and I can look at that and I can see I've got some files in there, and some of those will make some sense to you a bit later on when we look at running some of the other sets of the material with running jobs on ARCHER2. But that directory, so we might, for example, that directory is not by default available within our running container, but we might want to make that available so that we can access some files when we run jobs. So to show you something that looks much more similar to what was the example in the material, we could see there was a work shared directory that was used there, and we've got exactly the same here. So we've got a work TA049 shared. So you should all have access to that directory because you're all part of that group for the course. So what we're going to do is we're going to bind mount that directory into our running Singularity container. So just to prove that this, just to prove how this is working, if I create my normal shell in Singularity container as we did before, so I'm going to go Singularity. Let me just go back to my home directory and the test directory that I was in. There's my hello world.sif. So if I run Singularity shell hello world.sif, I've got a shell there, and if I try to look at /work/TA049/shared, it doesn't exist. So we can see that there's no such file or directory, and you should be able to see the same. So clearly the directory is not present there. So if I've got some shared files or data in there that I want to access when running a job, I've got a bit of a problem at the moment. So what I'm going to do is I'm going to shut down that container. I'm going to exit out. This time I'm going to run it with the -b flag to bind my answer directory, and I'm going to bind mount /work TA049 shared. And what that's saying is make the location on the host system, work TA049 shared, available inside the running container. Bind it into the running container. So we run that, our container has started. But if we tried to run the command that we ran before this time, we no longer see an error. We don't see a thing saying no such file or directory as we saw before. We can see that it seems to accept that that directory exists, and we could create a file there. So let's create again our hello.txt. And save that. Okay, and we can now do the ls command again, and we can see that, oh, well, that doesn't look good. Oh, that was me making a mistake. I didn't write the file into the right place. What I should have done was created it in that location. I've created it in the current directory. I should have created it in like that. EA049 shared hello.txt. Let's just do that again. Okay, wait for it to save. It's a little bit slow saving there. It's doing it. Okay, right, so now if we do the ls there, we can now see that, and in fact there's another file there, so I guess somebody else has been successful in creating a file in that location. If you also call yours hello.txt, it will probably overwrite mine, which is fine, but we can see that there is there is a file in that location. And if we now exit from the container, and we now look in that shared directory on ARCHER2, then what we see is that files are there. So what we did was we effectively just made that location on ARCHER2 visible inside the running Singularity container using a bind mount. So we just kind of made that visible through into the container, so we could access files in it, and we could also write stuff to it as well. So hopefully that looks to you similar to what we saw yesterday when we worked with Docker. The other thing you might have noticed that's different here is when we worked with Docker, we used the -- mount switch, and we said what the source and the target of the mount were. So in Docker, we would have said we had to take the type was bind mount. We had to say what the source was. So that's the location on the host system. In this case, this example work said 19 shared. And then we gave it a second parameter, which was the target, which was the location where we wanted it to appear in the container. What we've done here is we never actually gave it a location where we wanted it to appear, and Singularity just made it appear at the same location as it is on the host system. What you can do if you want to is provide an optional alternative location, and you can see that shown here. So if you use colon and then the target location after the name of the directory you want to bind mount, it will appear at that location within the container. So what we could do if we look at our command that we ran again, so we say Singularity shell -b, we have this location that we want to mount, and instead of it just appearing at that location in the container, we want it to instead appear in somewhere else. We might call it my shared directory or whatever. It doesn't really matter, just as a demonstration. So we do that. So now if we try to look at work EA049 shared, it tells us that that's inside the container. That no longer exists. That's correct, because we told it to mount in a different location, told it to bind mount in my shared directory. So hopefully, if we look at my shared directory, we can indeed see that. You can see we have somebody there who is not a fan of VI. So we can see that that's now the directory has come up at that location within the container. So that hopefully shows you how the bind mounts work. It's pretty simple syntax, and if there's any issues there, do let me know. I'm just going to try and check in the chat if there's anything that I've missed. Do we have any questions there? So right, so there's a question there. If the directory already exists in the CIF image, will Singularity overwrite the mapping in bind? That's a really good question. I think the answer is yes, but we can actually test that. So let's pick a particular location. So so this is definitely not advisable. I was going to actually use that. Let me not. I won't use something like /etc because that's probably not advisable. Let's have a look in our. So let's just create a new container. Let's have a look in there and see what we've got in the way of directories. So how might we want to do this? We've got a whole bunch of different directories in there, and let's pick one that's not a sort of majorly important system directory. That probably isn't one. We could use /media might be an example, or yes, in fact /opt has been suggested. Maybe we'll, I don't know what's actually in /opt. There's nothing in /opt, so that's probably a great one to use. So what we'll do is we will say, so as you saw there, we already have a /opt directory present. There was nothing in it, which means it's a little bit difficult to demonstrate whether it's overwriting or whether it's replacing. But I think we will see that if we go to tell it to mount in /opt, we'll see that if I now look in there, the files are present. So it didn't give me an error saying there's already a directory of that name. It just effectively overrode whatever was there with the current mount. I wonder whether if we type mount, we can see that. I don't know if it lets us see that. No, it doesn't. So we can see there that yes, it does. As far as we can see, it basically overwrites what is there. I don't know if do we have any files in /temp. We have a lot of files in /temp. So in fact, one option, in fact, that's probably because that's showing us /temp from the host system. So that's probably not a good example. But yeah, hopefully that gives you an example. So yeah, there's somebody said it acts like an NFS mount. Yeah, in fact acts like any kind of Linux mount. If you mount a directory in Linux over a location that's already there, it just hides whatever was there before, and the files that are there are just basically the files that were there originally remain stored on the disk, but they're hidden by the mount that's been put in place. And when you then unmount the directory, the other files are visible again. In this case, we don't have that sort of control within the container. We have to do the mount at the time when we start the container. But yes, it does just effectively hide whatever's there and replace it. Yeah, so there's a question, is it overwriting only within the Singularity container even after you exit the container? So it's not actually overwriting anything, it's basically just masking what's there. So it's only at the point, so when you start the container and say you want to bind mount something into it, if you bind mount it to that a location that already exists inside the container, it's just for the life of that container. When you exit, the image is not, the image content is untouched. I hope that was what you were asking. Yeah, great. Okay, right. So we spent a little bit of time looking at these bind mounts, and I hope that is clear. One of the other things that we haven't gone into here is about copying data instead. So another option here is if you want files to be available inside your container, is to actually put them into the image as static data in the first place. So here we've seen that we can make a particular location on the host system visible inside the container just for its lifetime, from when you start it till when you exit it. That doesn't affect the content of the image itself. But another option for getting files, data files into your running container is that they are in the image in the first place. And that maybe sounds obvious, but something to bear in mind here is that obviously that affects the size of the image. If you've got a gigabyte of data files that you want to be visible when you start a container from an image, if you put that gigabyte of data files into the image in the first place, then your image will be 1 gigabyte bigger than it would have been otherwise. The benefit there is, of course, some sort of portability, because if you then want that data to be available every time you run the container, if you move the image to another location and the data is already in it, then you're moving the data as well. But bind mounting is certainly much easier if you're working on a specific platform where data is present and you know that you just want to access it on that platform. It's much easier to just bind mount the location with the data in it into your container when you start it. So that's just a little comment on that, but we will look at how to put data into images, kind of static data into images when we come on to building. So yeah, so just to reiterate the question about overwriting data. So it's not actually the case that when you bind mount something to a location in a running container, you're not actually overwriting anything. You're just effectively masking anything that was there. So if you bind mount to a location that already exists in an image when you start the container, the files in the image are untouched, but you won't necessarily, if you're using a location that's already present, any files that were in that location in the image are effectively masked out, and you can only see what's being bind mounted to that location. But it's only for the life of the container. You're not actually deleting anything. It's just the fact that you're kind of masking out some stuff that might otherwise have been visible if you didn't bind mount to that location. I hope that makes sense. Right. Okay. So we can now look at another really useful feature of Singularity, and that's compatibility with Docker images. So Singularity, we've seen so far, can start these containers that are based on CIF file images, and we saw how we can pull those images from Singularity Hub. We saw it with the simple Hello World example. But as we also saw, Singularity Hub is a much kind of smaller repository than Docker Hub. It's kind of more specialist, I suppose, than Docker Hub, which has got now a phenomenally large number of images on it. And so a huge benefit of Singularity is that it's able to take images directly from Docker Hub and work with them. And so when you run a Singularity container from a Docker image, it doesn't actually run using the Docker image directly. It first converts it to a format that's suitable for use by Singularity. And while it's doing this conversion, the approach from the user perspective is a seamless one. So you don't have to go through multiple steps yourself. When you tell Singularity that you want to run a container that's based on a Docker image, Singularity will go and pull the Docker container, the Docker image, and it will pull the slices or layers of that Docker image and convert them into a single file CIF image. And then it can run that. So there is a conversion happening from the original Docker image into the Singularity CIF file format that we've seen this morning. But that's all done kind of, it's done in a kind of seamless way, and it's transparent to the user who just sees the thing running straight away. What I'm going to show you is how to do that in a kind of through a manual process, so you can see the actual process of pulling the Docker image and having it written out as a CIF image. So if we want to move on from the very simple Hello World example that we've been using and use something that's a little bit more useful, we could look at one of the official Docker Python images. So if we look in Docker Hub, so I'm going to open that link there, just wait for it to load up. We can see that there are some official Python images in the Docker Hub. There's a huge number of different versions of these images with different tags. If we pick a particular one, and I think we were using 3.9.9, it looks like it's now up to 3.9.10. That doesn't matter. So if we go and pick one of these, and we can see that there's the Dockerfile that's been used. That's the actual image that we're going to work from. If we look in the tag section, we can actually see the details. That's what I was looking for. So here we've got the tag, all the details of the images. These are the Docker Python supported images. And if we look at 3.9.10, we can see that there is a hang on, I think I'm looking at the wrong one there. What I was hoping to find was the base image and show you how big it is. In fact, maybe that was not the wrong one. So you can see these are reasonably big images, 2.11, 2.11 gigabytes, 2.58 gigabytes for the different formats. But we're going to use one of these as an example. There should be some smaller ones. There we go. Yeah, so we can see that there's versions for different systems, and the basic Linux AMD64 Python 3.9.10 image is 300 megabytes, so it's reasonably big. But we're going to use this as an example, and you'll see how this is converted into a Singularity image. So we're in fact going to use the slim image, not that big one. The slim one is quite significantly smaller, so it will be quicker for you to download. I don't know why we didn't see that on there. That was probably me missing the. Let me see if I can find the. Yes, there we go. That's better. Right. So down here, I should find the 3.9.10 slim image. I'm not quite sure where. I won't spend lots of time going through looking for it, but it will be in there. So that's the one we're going to use. Is 3.9. I'm using 3.9.9 slim here, but it's been updated to a newer version. So what we can do is we can say Singularity pull. We saw that this morning when we pulled from the Singularity Hub. It's exactly the same syntax as we saw this morning. So Singularity pull. The file name that we want to write the image to on the local system. So in this case, Python 3.9.9.sif, and then the place where we are pulling the image from. And of course, this morning we used shub here to say we were pulling it from Singularity Hub, and then we put the details of the user and the image name. And here it's, as we saw yesterday with Docker, it's very similar syntax. We're telling Singularity to pull from the Docker Hub, and we're saying we want to pull the image from the Python repository, the Python part of the repository, and we want the image with the tag 3.9.9 slim buster. Buster is a release of Debian Linux, just one of the Linux distributions. It's just they just put that name there to tell you which release it's based on, I guess. So that's what we're going to do, and we're going to try and pull this particular Python image. So I'm still in a container here. I'm going to drop out of that container, and let's go back to my home directory. So there's my home directory on ARCHER2 on the login node. Just before I pull that, have we got any questions that I'm missing anything from here? So there's some people getting warnings. Okay, so some people are a little bit ahead there. So I'll come. So there's a question there. Why is Linux so much smaller than Windows? I guess I'm not actually sure, but I think the Windows image was actually the Windows operating system with Python installed on it. So it would basically be an image containing the whole of the Windows operating system. I think that's correct. I don't know if I'm.
I've never used the Windows one. It could be that it's Windows subsystem for Linux based. I'd have to look in and read a bit more about it to understand what the Windows container actually is, because Linux containers usually require, containers usually require a Linux kernel. I'm not sure there's a native Linux Docker support. There's not. I'm not sure there's native support for containers in the Windows kernel.
Sure. Okay. Yeah. Okay.
So I'd have to read more. I'd have to read more what the Windows ones actually are to understand it. I can go and do that and come back to you and see if I can.
It's a good question, and we can certainly find out and come back. Yeah, absolutely. Yeah. So there's something about the warnings there. We'll see those in a minute, and I'll just highlight those. Okay. So we're going to try and pull this image. So we're in a location. We've got no images currently in this location. Just got a few files there. So we're going to pull this one. You could, of course, pull 3.9.10 if you wanted. We could see that that's now been released, but I'll just stick with the one that's in the material there. So we issue the command, and we see something happening here. And what we're actually seeing is that I'll go through what's actually happening when it's finished. Right. So what actually happened? So I'll just go through there. So that's the output that we saw. So we saw this message converting OCI blobs to SIF format. So this is basically Singularity telling us that it's taking some files, what it calls these OCI blobs. This is a particular format of the files, and it's going to convert them into the Singularity image format. And it gets the image sources, and the blobs that it's referring to here are these layers from the original Docker image. So this is the Docker image, effectively the layers being pulled down from Docker Hub, along with some kind of manifest or configuration. And what it's then doing is it's writing out all of these layers. It's effectively kind of crushing all the layers together into a single combined image file. And as was pointed out in the chat, there's a whole bunch of warnings that you get. These are on this particular platform. They're not a problem. They're kind of standard warnings you'll get every time. It's basically telling you that it's trying to do something with the file attributes on the file system, and the particular file system that's being used here doesn't support that particular operation. So that's why it's telling you that, but it's not an issue. And what it tells us at the end is it's creating the SIF file. And if we go and have a look, you do see indeed that there is a file that's here, Python 3.9.9 SIF. It's just about 41 megabytes in size, so it's a whole lot smaller than the full-size images that we saw on Docker Hub. But that's our Python 3.9.9 Singularity image that's now available to us. So we can now run a container from this image as we would with any other image. So maybe you've already tried this. If you try running the 3.9.9 image, what happens? So let's try running it and see. So hopefully, if you've already tried this, you managed to run it. If you haven't, do follow along. And let's say Singularity run Python 3.9.9 SIF. What's actually happened is we seem to find ourselves there directly in a Python terminal, Python interactive terminal. So this is basically what we would see if we were, if you're familiar with Python, if you were on a normal terminal on your system and you typed Python, this is the environment that you would likely find yourself in. And it is a perfectly standard Python terminal. So we can do stuff like saying, writing general Python commands, import math, we could say math.py, we get the value of pi. And when we want to get out, type exit, and it exits. So we can see that we were able to successfully run a Python terminal, Python interactive terminal, from an image that we pulled from Docker Hub. So this was an image from Docker Hub. It's been converted to Singularity, and we run it in Singularity. And we can see that there was also something that happened there when we ran it, because it didn't give us just an ordinary terminal. It put us straight into Python. And if you remember, what we can do is we can say Singularity Inspect -r to look at the run script for that Python image. And we actually see there is a run script provided. It's slightly more complex than the one we saw previously, but it is basically setting up the command Python 3, and there's a bunch of other things there that it's setting some different environment variables and various bits and pieces. But what it's basically done is then executed the command, and the command as it's running is basically the Python 3 command to give us a Python 3 terminal. And hopefully that that worked successfully for you, and you were able to get into that and run some commands. I think that covers that section. So what we were going to do here was to actually see whether if you wanted to run a shell in the container. So it's all very well that we go straight into a Python interactive shell, but maybe you want to have a regular shell access to the container so that you can do some other configuration before you run Python. So how might you do that? So some of you may have already looked at the solution that was there or gone into that. If you recall from before, we looked at the use of the exec command. So we said, or in fact, we looked at both the shell and the exec commands. So if we were to have a look at the shell command, because that's probably the easier one, if we say Singularity shell, we now get into a Linux shell, not the Python shell. So if I was to say import math like I did before, doesn't know what that is, imports an unknown command. We're not in a Python shell at this point. We can do an ls. We can see that we're in the directory where we started the, I'm in my home directory from ARCHER2 that's been bind mounted into the running container as we saw before. But I'm in the environment of this Python container, and so I have Python 3 installed, and I could run Python 3, and we then get into the interactive terminal as we did before, and we can run simple Python commands, using that as an example, and we can exit out. What happens on the exit? We don't go back out into ARCHER2's terminal. We go back out into the container terminal, the Singularity container terminal, because we're running inside the container at this point. So hopefully everybody's been able to successfully get that to work. Do we have any questions at this point? So somebody's already put up the message there of the alternative way to do this using Singularity exec. So thank you for that. That's the other way that you can run this. So what I was going to ask you was what other options are there? And if we exit out of trying to run Python commands in the Linux terminal, if we exit out of the container, so we've now stopped our Python 3.9 container. If you recall, what we did just now was we used Singularity shell to start a regular Linux shell inside the container. The other way you could do that, which gives you exactly the same result, is to use the exec command. And you can say Singularity exec, the name of the image you want to run, and then you could pass it bin bash, or just bash if you don't want to provide the full path, but in this case, providing the full path. And we get exactly the same result. We're in a running container based on this image. Instead of using the Singularity shell command, we've basically explicitly said execute this particular command when you run the container. So hopefully that makes sense to everybody. And that's basically what we have in this section here. So that's going through there. So you can go back and take a look at that if anything was not clear, but do ask questions otherwise if there's anything that you'd like some more explanation on. Okay, so this concludes the first part of the Singularity material. So we've seen a number of kind of basic commands, and hopefully at the end of that you've got to the point where you feel comfortable with being able to get images either from Singularity Hub or from Docker Hub, and then be able to run containers from those. And this really has shown us some of the sort of the core commands for being able to just do basic operations. When we come on to the next part of the material, we're going to look more at actually how you create your own images and some of the more advanced issues of working with image creation and running images on different platforms. So what we'll do is we'll look at going from actually creating your own image, building your own Singularity image, right through to hopefully we'll get to the point where we're able to actually run a parallel job on ARCHER2 based on an image that you have created yourself. So that's our kind of aim for the rest of the material. So as a precursor to that, there's some sort of preliminary stuff that we're going to go through before the lunch break, which will hopefully get us set up for going down that path of being able to create our own images. So I'm going to start on that now. We will break for lunch in about 20 minutes or so, and we will then continue with that material, and that will get us through to the point where we can start actually building some images this afternoon using the various tools that we're going to see now. Okay, so I'm just going to take a 2-second break to grab something to drink here, and then we shall continue. If there's any questions, do put questions in the chat. Okay. Right, so we're going to continue now with this preparing to build Singularity images. So here we're going to make a little bit of a change to how we're working. So we're not going to be working now at this point on ARCHER2 just for the next bit of the material. We'll come back to ARCHER2 a little bit later. But instead, we're going to be working on building images using a platform where we have administrative access. So we've already seen we don't have administrative access on ARCHER2. That probably makes sense to us. We're going to instead need to have an environment where we have Singularity access to Singularity, but where we have admin access. Now, this gets interesting because we probably, most of us don't have a machine with Singularity installed on it where we have admin access, but we're going to look at a way to work around that. So as we've seen in the material this morning, this is just a quick recap. We worked on the platform where Singularity was pre-installed. We could do all of this kind of work with images as we've seen, and I've just kind of given you a quick review of what we did there. And we can see that there's lots of images out there. We can see there's all of the stuff that's on Singularity Hub and Docker Hub. There's various other repositories of images that are out there, and so you might think, well, basically everything I could possibly need is already out there. But actually, particularly if you're doing scientific work, if you're working with specialist software, if you're building your own software tools, it's quite often the case that you want to create your own images, or that you want to customize an existing image to provide some specific capability. And what we're going to look at here is how we do that. So we've been working in a non-privileged environment so far on ARCHER2, and we can't continue like that for the purpose of building images. There are some ways to build images, or there are some options for building images in a non-privileged environment, but there are various issues that are raised by these different options. The tools are progressing all the time, and their tools are changing, and there are different ways to do these things. So it's quite likely that in time there will be a viable solution for this. But so far, the preferred approach to building Singularity images is to do it in an environment where you have root access, and we're going to stick with that for our approach here. So the important thing to bear in mind here is that the system where you build your containers doesn't have to be the system where you intend to run them. Now, we saw this obviously with Docker. You can create your images, you can push them to Docker Hub, and then anybody can go and pull them onto another system and use them. just there's a message in the chat there. Somebody says they're getting a message, an error about disk quota exceeded. I'm not quite sure whether there's a problem there. Maybe one of the helpers can help with that. I'll carry on because I don't think that's probably relevant to the bit we're on now.
No, I'll have a quick look. It could be that because people have been downloading images, we didn't get
fine. Okay.
the project enough disk quota.
Okay, yeah, we'll look into that. Thanks for flagging that up. We'll take a look. So there are some different options for being able to access Singularity in an environment where you have root access. And as I say, you can then build your container on one platform, build your image on one platform, and then push it to an image repository, or just transfer it as a file. In the case of Singularity, as we can see, the images are very easy to work with because they're just individual files. So you could move that file to another platform and run it. Now, what we're going to be looking at here specifically is running in an environment with an HPC platform, so ARCHER2 in the case of this course, but you may have your own local HPC platforms at your institutions or have access to other such platforms. And with HPC, things get a little bit more complicated because traditionally it's always been the approach that you would build code on the platform where you want to run it. And that's because often these platforms have specialist network interconnects, they have other specialist infrastructure that ensures that you get the best possible performance. And often you need to build against the libraries that are provided on those systems to ensure that your code has the best possible performance when it runs. And that is still true to a great extent, but what we'll see here is how we can build a Singularity image on a different platform, on our own platform, be it a laptop or a server or something that we have access to, and then be able to run that on a remote platform. In this case, we'll demonstrate it with ARCHER2, and hopefully see that we don't lose too much in terms of performance. In fact, the overhead should be very minimal, and that will be a demonstration of the fact that this is possible. And it may still be the case that if you have very performance critical code that you specifically need to build it on the platform where you want to run it. But of course, working with containers gives us a huge amount more flexibility. So there are still major benefits in using this approach. So what we're going to look at here, there's 3 different options for how we can run Singularity in an environment where we have the necessary root access. The first one is running from within a Docker container. And as we recall, when you run a Docker container, you have root privileges. So if you have a Docker container that's then got Singularity installed inside it, you should have the necessary root access. The second option is to install Singularity locally on a system where you have admin access. So perhaps you've got admin access on your laptop or desktop that you're working on, and you could install Singularity there. And the third option is to use it on a system where it's pre-installed and you have admin access. It's possible that you might, for example, have an Office desktop system if you're working in a research group or whatever. Maybe you have a system where Singularity is provided and you have admin access. But I know that's likely to only be a small number of cases. So what we're going to do here is we're going to use option 1. If you want to use option 2, so if you do have Singularity installed locally on your laptop, so Singularity needs Linux at the moment to run. So if you've got a Linux machine that you're working on and you've been able to install Singularity locally, then that should work fine for the steps that we're going to look at here. But what we're going to focus on here is option 1, running Singularity from within a Docker container. So this is a great opportunity to leverage your Docker skills from yesterday. So this will demonstrate a real-world use of Docker, where we can actually take advantage of the fact that Docker provides us with this kind of sandboxed environment where we have privileged access within the container that we run, and that will mean that we can then run Singularity within the container and have the required root access. And so that's what we're going to do here. So what I'm hoping we can do just before lunch is get to the point where we can all see that we can actually run the Singularity Docker container, and then we will we'll stop for lunch once we get to that point, and we'll come back in this afternoon and continue with that. There's a question there about what are the advantages of doing this versus converting a Docker image. That's a really good question. I guess the answer to that is that Singularity images, I was going to say that there are benefits from building Singularity images separately. I think if you've got a Docker image that's available and you want to pull that and convert it into a Singularity image, that's absolutely fine, and you can do that. The reason that we're working specifically with building Singularity images here is A, to give you the skills to be able to do that, so you can see how it works, and B, to kind of work within a fully kind of Singularity environment. If you're building stuff for running on HPC platforms, I guess there's probably not a major problem with doing that. There are differences in the way that the disks are converted and things. So you've got where the images are converted, so you may encounter problems with certain aspects if you pull a Docker image and convert it. It shouldn't be a major problem. Really, we're covering this to show you how the building of Singularity images works, and to show you how to basically work within a kind of Singularity environment to undertake this process. But if you are more comfortable working with Docker images, then it's certainly an option. I wonder whether maybe if there's anybody else who's got any kind of thoughts on arguments for and against, then do feel free to tell us. I mean, the main reason that this option exists, I guess, is because previously Docker images were not directly compatible with Singularity. So Singularity always worked with images of its own format of images, and you would create your own images separately. But I think there's something to be said for if you're working specifically, if you're building something specifically to be used in Singularity, then there is a benefit to building your image as a Singularity image, and then working from there. So there's a question there about, is there a good Singularity repo on Docker Hub? So the answer is that we are going to be using the Docker Singularity image that is provided by the Singularity team, and that's not hosted on Docker Hub. So there are various reasons why I think they moved away from Docker Hub, but they use another repository which is very similar to Docker Hub called key.io, and we're going to see that in a moment. So the official Docker Singularity images are on key.io. So as Andy's just said there, his workflow is now to build the image using Docker and to push it to Docker Hub and then pull it from Docker Hub. So it's certainly an option, but we're giving you all of the different options here and giving you the sort of skills to use all of the different approaches. And I think certainly if you're building something to work on HPC within a Singularity environment, then there's a benefit to having a recipe to build the Singularity image directly, and we'll see how that works when we go through this section. So we're not going to go through anything about installing locally, but as I've said, if you have the expertise to do that and you've done it, then that's absolutely fine. But that's not something we're going to focus on here. We're going to focus on using this Docker Singularity image. There's also a note here about other options where you don't have administrative access, and we've highlighted this fake root option, which is an option that allows you to, in theory, to build images without having root access. There are potentially issues with file permissions if you do it that way. So that's something which, again, we don't go into in detail. We're not going to look at that as an option, but it's something that is there, and we just want to flag that it exists. But hopefully, hopefully most of you will be able to use the approach that we're covering here. One thing that Andy has mentioned there is that one of the issues with building images is particularly an issue with building Singularity images. If you're running on a Mac with an M1 processor, there is a bit of a challenge, because what we're trying to do is to build an image that will run on an x86 based HPC system. And so trying to build an image on an ARM system that will run on an x86 system adds significant complexity. And so you need something that's capable of building an x86 image on an ARM system. Now, Docker does provide support for doing that. At present, I don't think that doing that on Singularity is straightforward, and certainly we found that there are issues with that. So if you're working on I wonder if I just put a little poll up to see whether how many people this actually will affect. So let's just put a poll for that. See whether we get any responses there. we've certainly got a couple of people.
One of them is me, though, and I know the solution.
I was just going to say, is one of those Andy? It is, yes. So that's good. Okay, so it's not something that's going to affect most people, but certainly, certainly, we've got one person there. So
you'd hit the
okay,
same problem. You'd hit the same problem if you were using a Raspberry Pi as well.
Yes, that's true. If you were using a Raspberry Pi, then you would also be working with an ARM processor, so potentially you would have the similar problem to work around. Okay, so it's not something that's affecting the majority of people, so there's a question there: do other variants get built when you push to Docker Hub? So I think, if I understand correctly, what you're asking there is, does Docker Hub somehow convert the variants to different architectures? Is that the question?
Yeah, exactly. Like, as I understand it, Docker doesn't virtualize the processor, so somewhere they must be building different variants.
Right. So my understanding is that's not the way that it works. As Andy's just put in there, you can specify this -- platform Linux AMD 64 flag when you build on an M1 system, and I think that there is actually obviously that infers that there is support built into Docker, to the M1 build of Docker, to be able to create x86 based images. So I mean, the mechanics of how that works, I don't know, but there is clearly functionality built in to be able to do that. So I guess it's effectively like. Well,
so what it tells it to do is to pull the layers associated with that architecture, right? And
okay,
because the build actually runs in a container, you're running in a container of the right architecture, so everything just works. And because Macs, M1 Macs, have this magic thing called Rosetta that automatically translates x86 instructions to ARM instructions, it just it all just works.
Right. Okay, so you're pulling the x86 layers and working.
So
on that
Jamie's exactly. So Jamie's right. You're essentially emulating on your in the container you're building on, rather than doing anything the other way around.
Right. Okay. So for anyone who is working on an M1 Mac, you will find that this there's a little bit more complexity here, and you might want to use the Docker approach, and that is an option. You're probably going to find that the approach we cover here doesn't work out of the box, but there is some information about doing this via Docker instead of doing it via the Docker Singularity image. So we actually provide a Dockerfile a bit later on, but do follow along, and if you're struggling to do this with an M1 platform, then let us know, and we can try and provide some help. Okay, so what we're going to do just very quickly before lunch is just to try and familiarize ourselves with the Docker Singularity image. So, as I mentioned before, there is this repository, image repository key.io, and Docker image comes from that rather than from the Singularity Docker image comes from that rather than from Docker Hub. So if I open that repository, what we see here is this is where Singularity Docker images live. If we go to the tags section, we can see that there's a huge number of different versions of the image, and there are in fact some ARM64 images. So if you're running an M1 Mac, you could try following along with this and pulling the ARM64 version of the image, although I think we did test this and found that there were some issues using that. But you can certainly give it a try. And you can see that there's a lot of versions, so they generate images for all the different versions of Singularity. And what we're actually going to do is we're going to work with version 3.7.3 of the image, because that's the version that's on ARCHER2, and it just simplifies things using the same version. But there's no specific requirement that you use that. You could use a newer version, but just for consistency with the version on ARCHER2, I'm going to work through this with the version 3.73, and I'm going to use the slim image because, as you can see, it's 82 megabytes versus 500, and if you've got to pull 500 version of the image, which is fine for what we want to do. If you do want to test with ARM with an M1 Mac, you'll note that the the first one where there's an ARM image is version 3.8.2, so you'll be wanting to use that instead. And you can also see it's much bigger than the version that's provided for the slim version of the x86.
And it will create a container that you can't use on ARCHER2 because ARCHER2 doesn't have ARM processors.
Right. Yes. Okay. Yeah. So you can certainly you can go through the process and create the image, but you won't be able to push it across to ARCHER2. But we will provide you with a version that is available for that if you would like to use it. So yeah, there's a point there about building on it on x86 for ARM64. So building on x86 for ARM64, if I understand that, you're talking about going the other way. And I think the answer is, yeah, if you're using Docker, it's workable. I mean, this is, of course, something which has only really become an issue very recently, because previously laptops were generally working in an x86-based environment. But yeah, that's something that is a challenge to work with. Okay, so in view of time, let's just see if we can get to the point where we can get this image running, and then we'll break for lunch. So the aim here is to familiarize yourself with the Docker Singularity image. I'll come back and go through this after lunch again, just to give you a kind of quick run through. But what we're going to try and do is to run a Docker container based on this Docker Singularity image, and we're going to use that as the basis for our building of images after the lunch break. So the image that we're using is this version 3.7.3 Slim that comes from key.io, and the exercise here is to actually run an image from that, run a container from that image. So what I'm going to do is I'm going to switch back across to my terminal on my local machine. So I'm going to close this container on ARCHER2, and I'll exit from ARCHER2, and I'm going to switch across to here, which is a terminal, just a regular bash terminal on my laptop, and I'm going to start the Docker. I'm going to run the Docker Singularity container here. So the container that we're running, as we saw from the key.io repository, if we go back to here, it tells us that we should be able to do Docker pull. Help if I actually have Docker running. Let's just fire that up. So we can see here we've got this Docker pull key.io singularity. So that is the command that we want to pull the image, and we then want to append the tag onto the end of it that we want. So I can copy that by clicking on it. I can go and find the tag that I want. So we were going to use 3.7.3 Slim. So if I go back to my terminal, I can say Docker pull key.io singularity v3.7.3 Slim. Oops, it's not started up yet, Docker. Just give it 1 second. I've forgotten to start Docker before, which was, it should be, there we go, right, it should be running now. Okay. Right, so in fact, it tells me it's up to date because I've already got the image. And given that I've already got the image, I should then be able to go Singularity, go Docker run. And what we see is something which looks exactly like what we would have seen if we just run the Singularity command on ARCHER2 without any options. So we just get the help out from the Singularity command. So just being able to get the container and run it should be as simple as that. To be able to do anything useful with it gets a little bit more complicated, because what we want to be able to do is, if we want to be able to run the creation of images, and then we want to be able to write those images out somewhere, we need a location on our host system to write them to, as we saw before with the bind mounts. If we run our container, do something in it, we want the files that are in it to be available to us once the container shuts down. So we need to bind mount a directory into the container, such that when we do stuff inside it, so in this case, when we build our Singularity image inside the container, we want a location where we can place it, where it becomes available on the host system once the container is finished running. So we're going to have a bind mount to do that. We also need to specify the privilege switch. That's just something that you have to do within Docker when you're doing privileged when you're undertaking processes that require privileged access within the container. So we need to specify that, and we're also going to provide the --rm switch, which I think we looked at yesterday, because every time you run the container, so every time I run this docker run command, I'm starting up a new container, and when that container exits, I get a kind of stale stopped container sitting there in my Docker containers. So I don't want that to happen every single time I run the command. So I'm going to use --rm. So I'm going to have to make a few additions to this. We'll see shortly how we can use an alias to avoid having to type this incredibly long command every time. But what I'm going to add is my --rm. I'm going to add my --privileged. And because at some point I might need to have interactive access, I'm going to add -it. These are all, other than privilege, these RM and IT should be things that you saw yesterday in the Docker lesson. This is a really nice example of making use of all of the functionality of Docker to be able to run this thing. And I need to be able to have a location that I'm going to bind mount. So we'll deal with that in a second. So let's just show that we can run that. And we just get the help out, and that's fine. But we also want to bind a location on our system into the container. And I'll open this up so you can see. So that's basically what we've been doing so far. We've run the container like that. There's a demonstration here of how you can run the container with an interactive shell. We'll come back and look at all these after lunch. So I'm just really showing you kind of where we're going with this stuff. And then there is the use of a bind mount and creating a directory into which we bind things. So we'll look at that. So hopefully you have got to the point where you have at least been able to just run that container. You've been able to pull and run it, and we will pick up after lunch with just running through this again and then going through these various exercises, and then that will lead us on to actually being able to run to build an image, a Singularity image, via this container. So okay, I hope that's been useful for everybody. I hope you've got a bit of a feel for what Singularity does and where it's similar to Docker and where it's different to Docker, and also that you feel that you've now got some confidence being able to run the basic Singularity images, as we saw we were able to do on ARCHER2. We'll pause there and we'll have an hour's break for lunch. We'll be having a slightly shorter break than yesterday. I know we had a little bit more than an hour yesterday because there's quite a bit of material to get through here. So we will start off again at 1:45, so just an hour's time from now. So that's 1:45 UK time, and we will continue with looking at the container, building or image building process via this Docker container. So do have a nice break for lunch. Hopefully where you are it's nice and sunny like it is here. And you get to take advantage of the sunshine. But we'll see you back here in an hour's time. And if you have any questions, I'll stick around for another 10 minutes or so. Happy to answer any questions, and we can pick up with any other questions when we restart. So thank you all very much, and see you in an hour. So there's a question there about how many days will ARCHER2 be available. So Andy's probably the best person to answer that, but as far as I'm aware, that it will be available for a period of time after the course.
Yeah, it'll be 3 to 4 weeks. So after this course finishes, there are 3 to 4 weeks of access on the ARCHER2 account for you to try out and use what you've learned to play around with it. And if you still have questions, if during that time you have questions or come up with things that you don't understand, you want to ask, then you can drop a line to the Archer service desk. Say you're on this course, and the questions will get pointed to me, and I can always ping Jeremy as well, and we can make sure we can answer them. So, okay. Lorenzo,
there's a question there about Docker
Yeah.
run. Sorry, Andy, you were going to take that.
Yeah. Docker. Why does Docker run behave like Docker container run? This is what we. Yeah. So this is part of the change of syntax. We said at the start yesterday we were going to use the more modern, up-to-date syntax for Docker.
Yeah, I apologise. That was partly my fault. We're still using the old syntax.
Yeah. So the old syntax from Docker was Docker run, and it just sort of inferred what you wanted. In the new syntax, which is much more consistent, it's Docker container run. It's as simple as that. They are essentially the same command.
So I changed to using the new mount syntax, but I'm afraid I forgot to change to using the new run syntax.